Find a power series for the function centered at C and determine the interval of convergence. So we'll let f of x be 1 over 1 minus 3x, and c is going to be 0. Now this is a geometric series with ratio 3x. We know that 1 over 1 minus x is of the form x to the n. So if I have 1 minus 3x, and here n goes from 0 to infinity, if I have 1 over 1 minus 3x, I'm just going to replace x with 3x. Okay, this is a geometric series, so we want the ratio to be between 1 and negative 1, and we do not want to include 1 and negative 1. So that means x has to be between 1/3 and negative 1/3. And so this is the interval that we're interested in. Next example, we're given the function f of x is 2 over 2x plus 3, where c is equal to 0. So our goal is to make it look similar to 1 over 1 minus x, or 1 plus x. Okay, so first let's factor out a 2 from the top, and then we're going to factor out a 3 from the bottom. So we can think of 2 over 2x plus 3 as 2 over 3 plus 2x. Factor out a 3, we have 1 plus 2/3 x. So in other words, that's 2/3 times 1 over 1 plus 2/3 x. This is a geometric series with ratio negative 2/3 x. And we know that 1 over 1 plus x will be of the form negative 1 to the n times x to the n from n equals 0 to infinity. But here, x plays a role of x plays the role of 2/3 x. So we have 2/3 times the sum from n equals 0 to infinity, negative 1 to the n, and then in parentheses we have 2/3 to the x, 2/3 x to the n. So we have the sum from n equals 0 to infinity, negative 1 to the n. And now we're going to bring the 2/3 inside the sum. And it'll be 2/3 times 2/3 to the n, which will be 2/3 to the n plus 1 power. And then we'll have x to the n. Now we want to see the interval of convergence. Because this is a geometric series, we want to make sure that r is between 1 and negative 1. R we set as negative 2/3 x. So I'm going to divide both sides by negative 2/3. So that means multiplying by negative 3/2. And because we're dividing by negative, we want to flip the inequality. So x has to be between negative 3/2 and 3/2 in order for the series to converge.